Hi, this is Yuji. In my presentation today, I will start with project review. I will briefly summarize what we did in Tula project. Then I will talk about what I have done to improve this project. In the third part, I propose some improvements regarding the predicting purchasing behavior, which are the sequential pattern mining, sequential market basket analysis, and the improvement for turn rate analysis, which is clustering and further analysis by gathering more data. Finally, I will justify why these improvements are beneficial to clients. So the project review. The three objectives are defined by client. They are database architecture, predicting purchasing behavior, and churn analysis for auto delivery. Because Tula has a business problem that pulls data from various platforms. We recommended the Microsoft Azure because it is affordable, has 1 year free trial, and fast and convenient enough for current data management. We also found there's a need for predicting subsequent purchases, so we recommended market basket analysis that can identify the frequent combinations so that we can recommend customers to buy products that are potentially like. And because there are relatively high churn rate in auto delivery program, we recommend the decision tree model to analyze product size and frequency. Because according to user cancellation survey, their major reason to leave is having redundant product before their next delivery. It is a very comprehensive project that have covered almost all major business problems that is usually faced by startup companies, especially for e-commerce. We slowly changed our mindset from a student to a real-world business problem solver by fully considering the client company's existing information to design personalized methodologies and solutions. For example, we recommended the data warehouse type that most suitable for Tula's existing and future data volume and suitable for the budget, rather than recommending the most fancy data warehouse. In the purchasing behavior analysis, my colleague treats the whole historical purchase as a basket since customers usually don't buy a lot of product in one order. In the churn analysis, we consider the qualitative information, that is the cancellation survey, to focus on the key factor to analyze. We adjusted our methodologies as we analyze. And in the project, I am responsible for analyzing auto delivery churn rate. My partner is Yu Zheng, and we work together from the beginning to the end. There is no clear boundaries between the work we do, since we discussed everything that we want to present. So at the beginning, we identified the churn factors that are discount, which represent the affordability and the product quality, because I might quit the auto delivery program because the product does not work out. And in the proof of concept stage, we tested the churn rate in terms of the discount in different products. We found out that discount is not the major reason to churn, and analyzing specific product may not be effective because the rare purchases will lead to extreme values. Then we incorporate cancellation survey information to change our focus to delivery frequency and product size, as they affect the usage and redundancy of products. We also abandon personal factors that influence churn because Tula do not have a lot of demographic variable. Then to perform data analysis, we need to get data clean and structured as we want. So we cooperate with colleagues from data warehouse design team to select key variables and build up overall relationship in data warehouse, because everything needs to be consistent. Then we build up a decision tree model. we realized that all the product information will make the decision tree super massive and ineffective. So we cut the trees by first analyzing the overall product type. Then for each type, we build up corresponding trees to present the array. And finally, to make our result easier to read, we turn trees to tables to visualize. So you can see in the whole process, we keep questioning, testing, and adjusting, or exchanging information with other people in the group to improve and finalize the results. In this slide, I will propose the changes to our existing purchasing behavior predictive methodologies. Our team member Tianxin used market basket analysis, which gives static combination of products instead of a sequential flow of purchasing. You can see the result that it only counts the frequent combination rather than the frequent sequence. So I propose to use the sequential pattern mining that identify the frequent sequence patterns. Each sequence represents the item purchased by the customer at different times. A sequence is an ordered list of item sets. For example, in this database, the first sequence indicates that a customer bought some items A and B together, then purchased item C, then purchased item F and G together. Finally, purchased the item E. What we need to do is prepare the customer purchasing history to a sequence database or data table. This is kind of information we already have, and then we can set up the minimum support threshold. This is the minimum number of sequence in which a pattern must appear to be considered frequent. If we set 2, the results are the sequence at least appeared twice. So the output is like this. We can use the SPMF to perform this analysis. It is an open source data mining software, includes a lot of functions such as clustering and classification, time series mining, and sequence predicting. However, there might be one problem for market basket analysis, and this sequential mining analysis is that if Tula just have a new product or product that not bought by customer very often, but it actually have very high satisfaction, it won't present it as a frequent sequence. So we discount the rare items. Therefore, I will introduce another method to calculate how purchasing sequence will affect the following purchasing. The second method is sequential market basket analysis. Similarly, it analyzes the acquisition sequence from the observed product portfolios. So how is it different from traditional market basket analysis? Let's take a look at their algorithm. As introduced in the final presentation, one of the main measures of market basket analysis are confidence. It is a conditional probability of buying B given A was purchased. It is a probability that A and B bought together divided by the probability of buying A. Then for sequential market basket analysis, it calculates the conditional probability of buying B after purchase A. It is a number of purchases of the B after A is purchased divided by the number of purchases of B after A is purchased plus the probability of purchase A alone. In other words, the probability of A to B is the probability of buying B after having bought A, and exclude all the scenarios where B is purchased before A. Then we can calculate the gain. It is a value we got from previous step divided by the probability of buying B, then minus 1. It is a percentage gain or loss in purchase probability for product B due to the purchasing A. So when you compare with two measurements, you can see that the gain measures how prior purchase of one product affect the likelihood of subsequent purchase, whereas the confidence, support, and lift only implies the joint occurrence of the events. And the most interesting application of this method is the rules it gave. By assessing the magnitude and positive negative sign of the probabilities, we can see the relationship between different products. They are the weak and strong HB frequency, complements, substitutes, and independence. Students might be more interested in the strong A to B sequence because their product function and type are very clear. So we don't need to see subsequent substitutes and complements. The strong A to B can give Tula a clue what is a gateway product. So what does it mean? It means that prior purchase of A increases the likelihood of buying B, while the prior purchase of B reduces the likelihood of buying A. So in this scenario, A is a clear antecedent of B. The advantage of this method is that because observed purchase sequence are affected by website layout, this method is able to normalize this kind of situation by number of times a product is purchased first. That's how it corrects for the sample size differences. So it won't affect it. So it won't discount the rare items, but see how purchasing A affect the probability of purchase B. Then I also propose the changes, improvements for auto delivery program, that is using cluster analysis first. It is a method that grouping customers according to their main characteristic. For example, we can measure customers' purchasing power using their average value of an order, and loyalty, that is the number of auto delivery completed before the churn. And the effectiveness, that is the number of auto delivery program enrolled simultaneously, or the time between orders. We can list these variables like this. First of all, customer ID and his or her corresponding characteristic, and the cluster analysis will output the different type of clusters that they belong to, and within one cluster, the customer's characteristics are very similar. And then we can combine it with the decision tree analysis we just did. That is, classify and predict the churn rate for each group under the product category, delivery frequency, and product size. I would prefer the combination of cluster analysis and decision tree model because this method, the cluster and predict, usually have higher goodness of fit, and compared to a simple decision tree model, it captures the differences, different behavior within each group. So it makes us it makes our churn rate prediction more accurate. And finally, this is my suggestion for Ticula for future analysis. I would suggest Ticula to gather more customer personal information such as gender, birthday, because if we know the birthday, we can know their age, and we can also give out birthday gift when it's their birthday. And most importantly, skin type, skin concern, or even the occupation category, because different kind of customer have different preferences and concerns that will definitely affect their purchasing behavior. So this information are all very helpful to identify the customer cluster and predict purchasing behavior and churn rate. So why actually do we need to know what can we do about the sequential result and clusters? So first of all, most importantly, we can identify the gateway products by measuring how purchasing product A will affect next purchase. And by using the cluster results, we can actually know that different type of customer can have a different gateway product. So once we know that, we can use the recommendation system or personalized targeted email marketing to recommend customers buy a gateway product. So for recommendation system, like the screenshots I share here, we can display this kind of recommendation when customers is viewing the web page, or when they put their product into the cart, or when they check out, or when they enroll in the auto delivery program. And then as for this personalized and target email marketing, we can recommend the product or give discount offers, or giving reminders to the customer by their location, by their skin concern, or even by the past order. The personalized and target email marketing will make customers feel that will improve the customers' using experience and customer satisfaction. That's all for my presentation. Thank you so much for watching. Thank you.